Thank you for joining us for the Regulatory Authority's Town Hall on offshore wind. This is a public consultation. You are invited to hear and understand the latest research that the Regulatory Authority and team have concluded. We encourage your feedback and your respectful dialogue throughout this process. The public consultation ends on September 15th. So you have between now, you can do all your talking tonight, or if afterwards you have other questions you'd like to ask, you can go to the RA's website at www.ra.bm and upload your questions there, and they'll be sure to answer you, to respond to you. This is offshore wind can be thought of as a somewhat controversial topic, but just know that no decisions have been made. No decisions have been made yet. No decisions will be made tonight. This will go towards the Regulatory Authority's decision making. Okay, and I just want you to feel free, feel relaxed. We've got refreshments in the back there for you. We're going to try to end on time at 8 o'clock, and we will have I will introduce the presenters to you, then we will have the presentation and questions and answers afterwards. I'm also encouraging you to come forward in your seats so you can read the writing that's on the screens, or if you feel comfortable back there, that's fine, but if you don't have the vision of Superman, you should come forward so you can read this. Also know that the presentation is on the RA's website as well, so you can review it at your leisure. Again, that's www.ra.bm. Right now, I'm going to introduce you to the Regulatory Authority's Chief Executive, the CE, Mr. Abayomi Carmichael.
Good evening. The RA is pleased to welcome you this evening to the Offshore Wind Stakeholder Engagement event. We have some interesting information for you and equally look forward to your questions and comments on what we have to share. But first, some brief background on who we are and how we got here. By law, the RA regulates Bermuda's electricity sector, and we're looking to foster competitiveness within it. As a regulator, we must balance all stakeholder interests and only intervene where positive outcomes in the sector would not otherwise occur. For electricity, that boils down to regulating two things: rates and service quality. In the distant past, service quality was focused on a reliable supply. Will the lights come on when I hit the switch? But today, Bermuda's residents and businesses, long accustomed to reliable supply, are increasingly expanding the scope of what defines service quality. Today, consumers increasingly are asking, what's the carbon footprint of the generation source that's serving me? How much of my energy is local? What environmental, visual, health, social impacts are being incurred? How stable will my electricity rates be during a global economic crisis? How resilient is the supply during extreme weather conditions? And in what direction are all of these measures headed? The RA and the electricity sector must find answers regarding the service quality and rates of the future. With these questions in mind, we are pleased to present today our initial findings regarding where we are and where we could be headed with offshore wind. How did we get here? The Electricity Act requires an integrated resource plan to be developed and periodically updated. It seeks the lowest cost, or otherwise most appropriate, plan to meet future electricity demand. It considers each candidate's technical, economic, environmental, and social merits, plus public interest, and government ministerial direction. It is a living document, this IRP, that is periodically reviewed. The 2019 IRP identified offshore wind as a potential candidate for bulk generation. And today we take another step in determining its viability for Bermuda. As Charmaine emphasized, no decisions have been made. This is a public consultation process. So we're here today to present our findings, seek your feedback on the possibility of an offshore wind farm for Bermuda. So please listen up. And once the mics are on, please speak up. It's important that you have your say regarding what may be a key feature in Bermuda's long-term electricity rates and service quality. So with that, I thank you for your time and attention, something we don't take for granted, and urge you to register your questions and comments. Thank you.
The presenters for this evening are Mr. Nigel Burgess and Martin Georgiev. I will give you a brief bio on each of the gentlemen. Nigel Burgess, you want to come to the stage, Nigel? He's the head of regulation at the Regulatory Authority of Bermuda, with responsibility for managing the regulation department, which includes the financial regulation and technical units for the electricity, electronic communications, and submarine communications sectors. Nigel's also responsible for ensuring effective regulation is developed and executed to fulfill the RA's legislative mandate as outlined in the Regulatory Authority Act 2011, the Electronic Communications Act 2011, the Electricity Act 2016, and the Submarine Communications Act 2020, the RA's work plan, and the RA's strategic plan. As a chartered electrical engineer with a specialization in power systems and control, he has expertise in renewable energy, having obtained his North American Board of Certified Energy Practitioners PV Installation Professional Board Certification in 2014. Nigel has been instrumental in shaping the regulatory framework for Bermuda's electricity sector and has helped to pioneer Bermuda's roadmap to a cleaner energy future as the RA's technical lead for the island's first Integrated Resource Plan, or IRP, which was released in 2019. Nigel also led a wide range of strategic initiatives, including retail tariff reviews for 2021-23, the preparation of bulk generation procurement rules, feasibility studies for both wind and solar PV developments, and the launching of the region's first floating solar PV solicitation. Martin Georgiev from Ricardo is a consultant with 5 years of experience in renewable energy, energy storage, and sustainable transport work. He's contributed to the successful delivery of multiple projects in the UK and internationally as a project manager and a technical expert. His experience includes a series of projects supporting the Regulatory Authority of Bermuda, including the delivery of an offshore wind scoping study and technical and financial analysis of solar PV. Additionally, Martin was part of multiple UK-based projects in the renewable energy space, focusing predominantly on solar PV, where he played a key role in carrying out financial assessments, technical analysis, and energy yield assessments. Martin holds a master's degree in sustainable energy systems from the University of Edinburgh, where his dissertation focused on offshore wind. Without further ado, I'll hand it over to Nigel.
Good evening, everyone. Thank you for your time today. So as Abayomi mentioned and Charmaine, we have been on a multi-year journey researching offshore wind and its viability in Bermuda. What we are presenting to you today is the results of those studies. There has been numerous studies, technical, environmental, and economical. So what we are giving you today are those results. There is no intent to, I guess, sway your support or for offshore wind in any way. It is strictly a presentation of the facts. We will go through the presentation, again, with an introduction of how we arrived to this point, how we arrived at a selection for a particular site, the environmental considerations for that site. We also look at the technical details for a concept design, and we look at the economics for that design as well. We also have identified several activities which we may need to what we term to de-risk the project, to solicit investment into Bermuda and interest, and the more interest from developers, with the intent to provide a purely competitive procurement process. And then we will look at the challenges and the benefits of a potential development. So we started on this journey for offshore wind back in 2019 when the regulatory authority published its Integrated Resource Plan, or the IRP. In that IRP, it was a target for Bermuda to reach 85% renewable energy by 2035. That was composed of 21 megawatts of solar and 60 megawatts of offshore wind. To date, we have 6 megawatts of solar installed, a utility scale, and the studies that we're doing now is to, again, test the viability of the offshore wind. For this project, we have identified 3 main work streams: what we term pre-procurement activities, which are these studies; a competitive procurement. Again, these studies are intended to support the competitive process; and post-procurement, which will be the construction and development stage. For our procurement process, we have, again, identified a 3-stage process, and in accordance with our bulk generation procurement rules. These rules lay out a fair, transparent way in how we intend to procure any bulk generation, whether solar or wind. This 3-stage is composed of an expression of interest, qualification stage, and an invitation to tender. So far, as I mentioned, we have conducted several studies. These pre-feasibility studies has included site screening, and we have engaged with numerous stakeholders in Bermuda involved in the industry, and we have also developed an environmental scoping study. And again, we will present that throughout this presentation. We looked at various locations all around the island. Actually, we looked at every single location, every inch of water around Bermuda, and we have narrowed that down to a particular site. It is off of North Shore, what we call the North Lagoon. It's about 9 kilometers off the North Shore. As you see here, the site is identified here in the red patch. There are 2 red lines there. Those are potential cable routes back to a central location in Times Bay, a Times Bay waste-to-energy facility. We have determined that there are potential benefits for an offshore wind farm. For one, it generates clean electricity. Bermuda and the world is moving towards decarbonization. This aids in that endeavor. It also helps to improve the air quality. And most important to customers, it helps to mitigate the volatility of fuel prices. As we know, we all have a fuel adjustment rate in our utility bills, electricity bills. Again, this will help to mitigate that volatility because it'll be less reliant on those fossil fuels. So where we are today, and how did we get here? Back in 2021, we started with pre-feasibility studies. Again, that helped us to identify barriers to a development. Again, and that pushed us to 2022, where we looked at additional analysis, desktop studies, and seabed assessments and wind measurements. Using publicly available data, we were able to determine that there may be possibility for wind, and it should be further explored. In 2023, earlier this year, we engaged in an environmental scoping study. Again, this was to help determine if there were any environmental red flags. And where we are today is presenting the findings from the past couple of years. And again, we hope to get your input on and comments on these findings. I will get to the what's next towards the end, so bear with me with the timeline, please. Our site selection and shortlisting of the sites. As I mentioned, we looked at all sites around Bermuda, in and around our waters, based on a suitability criteria. Again, we used a desktop-based study using publicly available information. Again, we looked to identify different types of constraints. We, again, consulted with various stakeholders at Department of Environment and Natural Resources and Bermuda Ocean Prosperity Program in BOP, otherwise known as BOP. So some of the characteristics that we looked at were seabed characteristics. The environmental constraints, so coral coverage, impact on fisheries and mammals. We also looked at the infrastructure constraints and conflicting issues for those particular areas, whether used for tourism or fishing, for example. Again, I will now hand it over to Martin to go into more detail on the shortlisting criteria.
Thanks, Nigel. And thanks everyone for coming in tonight. Over the next few sections, I will be talking for most of the time, bringing a little bit more detail around the process that we went through when we were going through the site selection and environmental studies, etc. So starting with the site shortlisting process, we went through a fairly thorough process looking at different criteria, different constraints that could be present. Without going into any detail on the figure on the right, these fall into environmental, technical, socioeconomic considerations that we looked at. And just picking out a few examples, things like shipping routes come into constraints that we looked at, protected areas in the environmental category, recreational zones, etc. So these two maps that you see on the screen right now, these are just examples of some of the information that went into the research. The map on your left that looks at the coral cover on the Bermuda pedestal, you can see there's very little in some areas in the lagoon, but the areas around the rim reef and the platform on the outside of the rim, there's extensive coral cover. The map on the right shows different protected areas. You can see fish spawning grounds to the west and east of the island. You can see protected dive sites, shipwrecks, and also you can see the coral preserve in green. So information like this, like these two maps, and many more were collated, and we started layering those different constraints, and we came up with this map. So this essentially looks at all the different constraints in aggregate. The purple area would be various environmental constraints that might be coral, seagrass, etc. We have the rim reef in bright green. We have complex topography, sort of complex seabed in the crosshatch. And you can see things like the airport, like the shipping routes and so on onto that map. And I suppose the conclusion from this is that there aren't very many places around the island where there's no constraints at all. There's always something that will be on the way. You can see a few gaps where there's nothing identified, and these were largely what drove the initial selection process. We identified 3 sites initially, 1, 2, and 3, that you can see on your screen. The first one is about 4 kilometers from shore in the lagoon, 4 kilometers from St. George's. The second one is to the west of the island, and the third one is Challenger Bank. Challenger Bank was very quickly dismissed on the grounds of distance from shore, complex technical solution. It needed to run a cable between Challenger Bank and the Bermuda pedestal, and there's significant depths between the two. The next one, the second best site, was Site 1, but this was dismissed on the basis of proximity to shore. It's 4 kilometers, so the visual impact would be quite significant at St. George's. So Site 2 was actually the one that we initially took forward, and we initially thought was the best possible one. So sorry, technical problem. Okay, so Site 2 was taken forward, but a new site was introduced as well, dubbed 1B. So that's a bit further to the north from Site 1, so about 9 kilometers from St. George's, which reduces the visual impact. And subsequently, Site 2 was actually dismissed. Based on Bob's draft marine spatial plan, we discarded it because of the fish spawning grounds that are located there, which we initially thought would not pose a significant challenge in terms of environmental constraints, but it was dismissed nevertheless. So Site B was the only one remaining, and this is what we are currently analyzing. It was introduced as a result of discussion with Denner, but it's important to note that there hasn't been any surveys that have been carried out at it just yet. Sorry, I'm struggling with the clicker. So Site 1B, it doesn't come without challenges. It's close to the coral preserve, so it's possible that a short section of one of the possible cable routes is going to run through the coral preserve, or alternatively, it would run through an area which has some coral cover and slightly complex terrain. The site is located about 15 kilometers away from within the 15-kilometer zone around the airport, so there's a height restriction. You can't build more at a height more than 150 meters in that zone, so that significantly limits the type of turbine that can be selected. Even though it's a bit further than Site 1, there's going to be some visual impact, especially at St. George's. And the area is used for fishing as well, so there would be some restrictions on commercial fishing, or at least some obstacles to it. Yeah. Okay. Right. So what I'm showing you right now, or trying to show you, is what we did in terms of visual impact assessment. So these are mock-ups where we have the turbines to scale. The first one is from Ferry Point. These are available over there in the flesh if you want to walk past and have a look at them from close by as well. You can see that the turbines are visible. They're probably not dominating the landscape, but they are still visible. Next one, if I manage to. So next one is for St. Catherine. And the backside of the proposed concept design is closer to that point. And you can see that some of the first turbines to the right are quite visible. And then the final one is Admiralty House, and this is looking at the turbines from a slightly greater distance. You can see that they're not as visible here, so less of an impact from that point. Okay. Again, I invite you to have a look at the printouts over there. They probably communicate the impact a little bit better, so feel free to have a wander. With this, I'm going to hand back over to Nigel to introduce the environmental study that we carried out. So, click.
So as I mentioned, we did an environmental scoping study. Again, not to be confused with a full environmental impact assessment. What the intent of this was to identify any barriers to moving forward. Some were identified, as we will see. However, we was able to offer solutions which we felt that mitigated these challenges to a manageable state. So in our site that we have identified, again, was through a desktop study. We assessed the potential environmental effects of a development. There were some challenges with the site. Again, there's a coral preserve located to the west. There are topographical constraints directly to the south. Again, not so much on the initial development, but the cable routes would have to go through this potentially go through this area. There were some other environmental and social economic impacts, and we will touch on those in a subsequent slide. It's in shallow waters. That's a potential hazard as well. I will hand it back over to Martin now to go more farther in depth on the actual extent of the studies which we had.
Thank you. Right. So what we did was we looked at a range of topics that range from environmental considerations, flora and fauna, but also infrastructure and socioeconomic factors. The study was based on a range of sources, some of them public, some of them prior work, and some of them specialized report that we obtained specifically for that purpose. We looked at the impact both at construction stage and operation stage, and they differ quite a lot. And it was a simple red, amber, green assessment, with red for significant impacts, amber for moderate ones, and green for minor impact. So I will run through the topics. I will not dwell on them too much because there's quite a lot of information, but if you go on the RA's website, you will see the public report, and you can review those in your own time, but the information is publicly available, as are those slides, if you want to revisit. So, as I say, we assessed the effect without mitigation, and we identified some mitigation measures, and then we assessed the impact after mitigation. And starting with landscape and seascape, we identified some red flags, but we believe that after the appropriate mitigation measures, this could be brought down to moderate impact to an acceptable level. Same with archaeology and cultural heritage, red flags present, but also mitigation measures that could bring those down to an acceptable level. With tourism and recreation, there are mitigation measures, but we don't feel like those could significantly bring down the impact. So there will be some moderate impact from this aspect. And then when it comes to aviation, air quality, socioeconomics, etc., there's no significant impact there. Moving on to the next set, we have flora, fauna, wildlife sites. Again, red to amber after mitigation measures. Marine water quality. During construction, there are some concerns, but those could be brought down to an acceptable level. And you can see that operation could be brought down to green, to minor impacts. With ornithology, there are some risks, as there are some mitigation measures, but the impact remains moderate, even after mitigation. There are some things that could be done, like soft start procedures and so on, to minimize the risk of collision, but it's important to note that some risks remain. And then we have insignificant impact on coastal processes, benthic ecology, and moderate impact from natural disasters. So what this envisages is what is the worst case scenario if these things fall into the water, there could be some damage. Right, fish and shellfish. Again, some impact identified, but also mitigation measures. Marine mammals and turtles, there are some red flags there. The key thing is the noise and vibration during construction from pile driving. This could be disturbing mammals. During operation, there's obviously risk of habitat loss and risk of entanglement, which is quite severe, but with the appropriate measures, this could be brought down to an acceptable level, we think, or alternatively pivot to a different technology. And commercial and recreational fisheries, some moderate impacts there, but also mitigation measures such as fishing within the array will be permitted, obviously with a safety zone around the turbines. Fishery liaison officers will be available to raise any concerns, and there would be agreed routes and clear markings of obstructions. Right, I've said quite a lot of negative things here, but there are beneficial impacts from offshore wind turbines as well. There's obviously things that Nigel mentioned, like reduced pollution and then reduced carbon emissions. So it's quite important to emphasize the positives after all the negatives. The other important thing is to say that this was carried out using publicly available information. It's not a full environmental impact assessment. Once a detailed design is ready, if this goes to procurement and there's a developer that comes up with a design, they would have the exact turbine placements and the exact type of equipment that will be used. Once this is available, they can proceed to full environmental impact assessment. And that would be the final document that is going to inform the environmental side of the project. With that, I'm going to hand over back to Nigel to introduce the next section.
Thank you, Martin. So when we look at the composition of a wind farm, it is technically quite basic, quite simple. It's composed of wind turbines on a foundation, on a post, a set of substations, typically ones offshore, connecting to an onshore substation. And you have cables which interconnect the turbines and the substations. In our concept design, it is 17 turbines and foundations proposed, and it'll be 17 cables feeding into a substation. Coming from the offshore substation, there will be one cable coming back onshore. Again, this is to help to mitigate the environmental impact of multiple cables coming back onshore. Again, quite a simple design, but obviously there are specifics for each component. And Martin will go through the specifics on the next slides.
Thanks. Okay, so first of all, turbines. You will have seen that the type of turbine that is the prevalent one in pretty much all developments is a three-bladed upwind design, and this is what we selected. This is the industry standard. The key feature of that turbine in the Bermuda context is that it has to be capable of withstanding hurricane-force winds. There are different classes of turbines, and it's important that the appropriate class is selected. The technology is out there, it is available, and other jurisdictions with similar extreme weather conditions have already started developing offshore wind. But it's important to engineer the solution to the appropriate standard. That means strong enough foundation, strong enough tower, the appropriate controls, strong enough blades, etc. We created a concept design and we opted for a relatively small capacity turbine. Initially that was driven by the desire to introduce flexibility into the system, meaning that having a large number of turbines with smaller capacity improves energy security, and also improves the flexibility in case one of them goes down. The grid could recover and could pick up the slack. If we have those large 15 megawatt turbines, that would be more difficult because they start to form a disproportionate amount of the generation online. With the 3.6 megawatt design, we opted for 17 turbines, resulting in 61.2 megawatts, which is in line with the IRP. But it is quite important to note that we fully anticipate a potential developer would opt for a different type of equipment. Those turbines that we have selected, they're probably a little bit dated now. So when a potential developer comes, if this goes to actual development, they might go for a 4 megawatt, 4.2 megawatt, different make, different model. But the key point is that they would face the same constraints that we identified. The proposed site being near the airport, the height restriction is 150 meters. So it wouldn't be possible to opt for the very largest turbines that are available in the market. Next up, foundations. We identified monopiles as a potential candidate for the seabed around Bermuda. From the information that we were able to find, we think that the sediment will be suitable. Obviously, this is pending further studies when the project proceeds. We think that they're suitable for the depths around Bermuda, and we also believe that them impacting a smaller area of the seabed, the environmental impact would be ever so slightly minimized. But the second best option would be gravity-based foundations in case the monopiles don't work for some reason. And this is essentially a slab of concrete, which is placed on the seabed. And then there's a transition piece and the tower is mounted on top of that. Briefly on electrical infrastructure, each turbine is connected to an offshore substation, to an offshore platform with a substation on it via an inter-array cable. So there will be, in the concept design, 17 of those cables running to an offshore platform where the voltage is stepped up, and then an export cable runs to shore and is connected to a point of connection on shore. We identified a potential point of connection at Tynes Bay, which is central. The grid is sufficiently reinforced there, and it could take the extra generation. And that results in about 17 kilometers of export cable. Now, this could potentially be minimized pending further research into the potential impact of the cable route. Right now, we are taking quite a conservative approach in the concept design, and we're almost completely bypassing the coral preserve, which makes it a little bit longer. But if it is possible, this could take a more direct route and shorten the distance. Okay, we have collated some industry insights. We looked at Southeast Asia purely on the basis of extreme weather patterns. So the first jurisdiction that we looked at was Taiwan. They are in a typhoon-prone location. They are on the path of Category 5 typhoons. Typhoons have the same classifications as hurricanes. And they develop offshore wind. They have a significant pipeline, 36 gigawatts. There are projects ranging from 10 megawatts to 4 gigawatts, and the first demonstrators that they developed are comparable to what is proposed here. We're talking about 100 megawatts, for example, compared to 60 in Bermuda. We actually pulled some cost estimates for those projects, and we can see that they are lower than what we are projecting for Bermuda, but comparable, which serves as a bit of a validation of the process that we've taken so far, the research that we've carried out and the costs that we landed on. You can see that the projects under construction, for example, they average about 5.7 million. And you will see when we start talking about the 5.7 million per megawatt installed, sorry. And you will see when we start talking about the economics that this is comparable to what we landed on. Another example is Vietnam. This one is interesting, less so because of the weather patterns, but more because of the type of projects they are developing. They have several ones that are of similar capacity to the one proposed here, and they managed to build those at a significantly lower cost. The key feature there also is the type of turbine they are using. So there are turbines ranging from 3.2 megawatts to 4.2 megawatts in the projects that we researched, and this is similar to what we are proposing. So these things are being built at the moment, so they're not entirely obsolete, which is encouraging. In terms of construction of wind farms, you'll see in the timeline that we've given ample time for the construction process, but the actual on-site installation of the turbines is quite a quick process. They are modular, meaning that you are essentially replicating the same process for each turbine. You have the same equipment, and then you're building another one and another one. In recent news, that we saw that the largest available turbine was one of the largest available turbines was installed in 30 hours, which is quite remarkable, I thought. And those short times indicate that the disruption from the construction process could be limited to a relatively short time window. That allows the flexibility to start construction in a season that would minimize the impact, or at least to some extent. Obviously, there are other considerations like hurricanes. I'll stop there with the industry insights, and I will move on to the next section and hand back over to Nigel.
All right, the economics. How much money are we talking about? So when we look at the cost of our development, we look at three aspects: the capital cost, so the actual cost of the equipment, the turbines, the foundations, the electrical infrastructure. We look at the development cost, the studies, the permitting process, partly what we are doing now and what we propose to do in the future, and the operating costs, so the cost of the actual operation, the leasing of the seabed, the maintenance, and insurance. So using publicly available information, we estimated these costs between 250 to 450 million, with a midpoint of approximately 350 million, which is about $6 per kilowatt. Sorry, 6 million per megawatt, which was comparable to Taiwan, again in a hurricane zone. When we look at the electricity generation, again using industry standard software, publicly available information, wind data was used, and our concept design of 17 turbines at 3.6 megawatts each. We're looking at approximately production of a third of Bermuda's electricity demand, 180 gigawatt hours. So we actually use these two parameters, so the cost and the electricity generation, for an indicator which we use for various technologies. And again, Martin will now look at that indicator and let you know how we actually use it and is able to compare it to other projects.
Yeah. In this slide, I'm going to talk about levelized cost of electricity. So as a metric, this is quite useful for comparing different energy generation projects. And using that metric, you can compare across different technologies as well. This is why it's so useful. So as a metric, this is essentially how much is it going to cost per kilowatt hour produced over the lifetime of the project. So you take into account the capital cost and then the operating cost and then the cost of that electricity with the appropriate discounting for the future. Our latest analysis shows that we arrive at a midpoint of 23 cents per kilowatt hour and a range of 17 to 32 cents per kilowatt hour. Now, this is not a power purchase agreement because this was done purely as an economic analysis. There are other factors that would inform the desired PPA of a potential developer, and in all likelihood, it's going to be higher than that. We have carried out a bit of a comparison with other jurisdictions in terms of offshore wind, but at this stage, we haven't compared with different technologies for Bermuda. The reason for that being that this is going to take place in the upcoming IRP, the Integrated Resource Plan. So I'll just speak about offshore wind in the US, the UK, and Taiwan, and you can see from the graph that they come at a significantly lower cost. The US and the UK around $100 per megawatt hour or 10 cents per kilowatt hour. And then Taiwan even lower than that at $85 per megawatt hour or 8.5 cents per kilowatt hour. And there's a very good reason for it. The costs in Bermuda are significantly higher because of factors that will probably be quite familiar to you. It's the scale. The project would be much smaller than many other projects around the world. Bermuda lies in a hurricane-prone location, so the equipment needs to be able to withstand that, which makes it more expensive. The average wind speed is actually not that high here. It's comparatively low with other locations that develop offshore wind heavily. And of course, there's the country context. Bermuda is a relatively isolated place, and it's a small place, so everything comes with a premium. So with this, I'm going to stop on the economic analysis that we did and hand over back to Nigel for the introduction of de-risking activities.
So we have identified a couple activities which we term de-risking activities. Again, these are what we have considered to primarily encourage the interest of investors or developers in the hopes that they would add or aid in a purely competitive procurement process. A purely competitive process is hoped that it will drive down the cost from the developers. So again, we have a good understanding of the implications for a wind farm in Bermuda. However, there are uncertainties. As you see, there's quite a wide range in the potential costs, $200 million range. So there are some activities. Again, these activities that we have identified will help to narrow that range. And again, this will help to increase its commercial attractiveness with these activities. So we find these to be quite prudent to do. And these activities is a wind measurement campaign. Again, it's a detailed site-specific wind measurement campaign at the actual sites of the development. Again, this is so that we can acquire, accurate estimates of the wind, accurate wind measurements, which will lead to the developers able to generate fairly accurate estimates for their energy yields. And again, the energy yields is how or their energy production will be how they will recover their costs or get their revenue. So it is a quite important data for a developer to have. Again, to help understand the cost, a seabed assessment. Again, this is a detailed survey of the area which is proposed. Again, we're going to be looking at the technical and environmental considerations of those sites. And this will aid, again, in installing the turbine foundations. It is also aids in analyzing the cable routes back to land and from the turbines to the substation. Again, quite critical information here that is needed. This information is typically done by the developers. However, again, we have identified that these de-risking activities is needed to be done prior to encourage the interest of developers. So I will hand it back to Martin to actually go into more detail of the wind measurement campaign and seabed assessment.
Right, so what we've done so far is based purely on publicly available information. We did a pre-feasibility study and we simulated the yield from a potential wind farm, but this was done on the basis of average wind speeds and some measured data that helped us inform some of the parameters that are needed for the simulation. But this is not an investment grade analysis. To have an investment grade analysis, you need measured data and very specific data. It's higher resolution, wind speed, wind direction, turbulence intensity, and so on. It's measured at the location of the proposed development or nearby, and it's measured at a height close to the hub of the turbine or at the height of the hub of the turbine, which means the center of the rotor. So we have estimates. We came up at 180 gigawatt hours generation, which is about 30%, but this number is not sufficiently accurate. So as Nigel said, it was deemed as a good pre-procurement activity to actually go a step further and measure those wind speeds before the procurement process for the generation capacity is finalized, and to have that data made available to a potential developer just to increase the interest of developers. So the next step would be actually to start that measurement campaign. It's what we believe would be the best option is to have a measurement device at sea, a buoy with a measuring device, and then a secondary measuring device on shore. Again, this is just a concept that we've come up with, and once this is procured, the entity that carries it out will design the measurement process in detail, and then make that data available. It's the same with the seabed assessment. Currently, we have relied on available information, which is not detailed enough. So the next step would be to actually do surveys. And typically those surveys are, there's a set of desktop studies, but then there's a geophysical study and a geotechnical study. The geophysical, that would be more scanning, drop-down video, sonar, aerial photographs, and so on, where the geotechnical is boreholes, cone penetration testing, and so on, different sets of studies. We engaged with companies that provide that type of study, and we were advised to carry out the activities up to and including the geophysical study and make that data available. The reason being that the geotechnical is quite location specific. And as I said, we have a concept design, but we do think that this concept design is going to change once a potential developer is brought on board, and they need to carry out the geotechnical assessment based on turbine placements and the type of turbine that they'll be using and the type of foundation and so on and so forth. So the first two steps will be undertaken prior to procurement of the generation capacity, and the final step will be left to the developer to finish. Okay, so I'll hand over to Nigel for conclusions.
So, as I mentioned, and as we have seen, there are challenges to this potential development, and there are benefits. When we look at the challenges, it's a risky endeavor. However, it also can be expensive. There are potential environmental risk. However, we will continue to evaluate the environmental risk throughout the entire process as we continue to engage with stakeholders. As you will see, this potential development is not slated, wouldn't be slated to start until 2026. Sorry, 2028. But there are benefits to an offshore wind farm. For one, and again, it helps Bermuda on a road to decarbonization. It increases our self-reliance and energy security. Again, we are primarily fossil fuel based at the moment. It will help us to diversify our energy mix, increasing our energy security. It will set a precedence in the region. In the Caribbean, this will be the first of its kind. On the East Coast, there are started developments. They are not currently in operation. So again, we have the potential to be the first in the Atlantic. Sorry, in the in the West Atlantic. Again, as part of the IRP, we sort of target of 85% renewables. This will help us to reach that target. Again, approximately 30% of our annual demand could be met. There is the potential for job opportunities. There's the potential for boat operators to support the construction during the operation. There is the ability for locals to be trained in the maintenance of these wind farms. And in other areas, other locations, tourism has thrived from these wind farms. Tour boats and even fisher boats have been converted to tour boats in sightseeing for these developments. Most importantly to customers, it adds a bit of stability to your electricity bill. It lessens the reliance on fossil fuels and the volatility which is experienced from world events. So when we look to the next steps, we are currently in the stakeholder engagement. The later part of this year, we look to start the expression of interest. Again, our main goals from the expression of interest is to assess the interest of developers and also get an idea of the potential power purchase agreement price, or the PPA. From there, next year, we look to start the procurement process for the seabed and wind assessments, and then starting those assessments towards the middle of the year. Again, 2026 is when we'll look to award a potential developer for starting of the project, and again, with construction starting in 2028. Between that period, we're looking at licensing, permitting, and the environmental impact assessment for the project. And again, completion or operation towards the end of 2029. So there is a significant amount of time and decisions to be made within that time before the start and even the operation of a potential development. Again, and that is part of our presentation here today is to encourage the feedback from the public. Let us know your thoughts on any parts of the information that we have today that is available on our website. We will use this information as this to help us in our decisions in moving forward. Again, to conclude, in our view, there is certainly potential with offshore wind, and we, in our view, that we should further explore the implementation of this development. Again, it helps to improve the air quality, our security of supply, and moves us towards a road for decarbonization. So some of our next steps, we will, as I mentioned, is we will invite developers to submit their expression of interest in developing an offshore wind farm. And once we have evaluated the expression of interest responses, we will look to procure or start the seabed assessment and wind measurement campaign through a competitive process. As you see here, the site here is off the North Shore. It's mostly visible from the east end. However, all of Bermuda is impacted not just visually, but I'll say environmentally, socially, socioeconomically as well, which is why we are taking our town halls throughout the island. So that I conclude and hand it back to Charmaine.
Thank you, Nigel and Martin, for your presentation. Thank you. At this time, the floor is open for any questions that you may have, any comments, any concerns. I can come to you, or you can just go to one of the mics in the aisle here. Anybody, any questions, any comments, concerns? Is anybody shy? Is everybody shy? Have you got something? Yes. Yeah, thank you.
I'll start it off with a question related to the costs, and thank you for presenting the information. And thank you for your whole presentation. I hope we find a good, environmentally friendly, safe, and reliable solution for Bermuda. I think it's our duty to do so, and it's important. So my first question would go to the question of costs. And so the cost ranges you were putting out, how does that relate to our current costs that we as customers pay? And are we talking about a reduction in our electricity costs as a result of this project, or an increase in costs?
So I will answer that in two parts. So the first part is that we are not entirely sure what the price will be. And that is part of our goal from the expression of interest, is to get an idea what the power purchase agreement price will be. And what we have now is levelized cost of electricity. Again, that is not the power purchase agreement. The midpoint of that levelized cost is, I will compare it to the cost of the feed-in tariff at the moment, which is the avoided cost of electricity, which is approximately 22 cents. So it's around that point. But again, the goal of the bulk generation developments is to significantly lower the cost of the current generation. So it is, we do not expect to move forward with a development if it will have an adverse impact on customer bills. So the goal of it is to lower the cost of electricity, again, with the appropriate trade-offs, whether it's environmental factors or for security of supply as well, taken into consideration. So I hope that appropriately answers your question. So in short, we don't know yet until we complete the expression of interest what impact there would be on a consumer bill.
My concern is to follow on from that question would be the interconnectivity to the rest of the island. At this point, we need you on the sorry. I'm concerned about the interconnect. I'd like to know about the interconnectivity. Obviously, at this point, with solar, when we send it back, we get the generation cost, not the delivery cost. And I'm very happy that I don't have to put the Belco lines up when the hurricane goes down to send my electricity back. But there's a distribution cost. Have you thought about that interconnectivity with regard to the funds and the rates that they'll be able to charge and the costs?
So the costs which we have presented today include all of the costs up to connection and full operation of a development. So it does include those costs as well. And I just want to add here that we are looking for, well, the intent is to look for international developers, reputable developers for as part of the procurement process. So the intent is not for a government funded project. Again, this is primarily solely for private investment or ones with a proven track record for development. And the way that they would recover their costs is through their power purchase agreement or their PPA, and from the energy that they produce. So if they do not produce, they do not gain any revenue. So again, I think any developer which comes in, they would understand the risk. Again, we are presenting the risk to them as well. And again, that would all go into their costs for the development as well. You want to add to that one?
Yeah. I suppose part of your question was about the risk from hurricanes and things being disconnected.
More the connectivity costs.
Well, the costs were included in the analysis.
Where they would make the price of a certain cost 23 cents, then where are they going to be able to sell it for, considering they have to deliver it to the homes and the hotels?
I think Omar.
Right. So I suppose the cost that we landed at, the levelized cost that I presented, this is based on the cost of the entire project plus the interconnection. There's going to be a markup on that, but the distribution to the homes and the hotels, etc. This is the responsibility of the TDNR licensee. It's not the responsibility of the generator. So this is going to be Belco and.
So this bulk generation, like a potential bulk generation licensee, will behave similar to our other IPPs or independent power producers, mainly Tynes Bay and Saturn Solar at the solar finger. They would sell directly to Belco, and then Belco sells on that generation at no markup. It is a straight pass through. Belco does not regulate that price. The regulatory authority sets that price for retail to customers. So I guess you could be assured that there will be no additional markups once a PPA is in place.
I'll come back to you. What we just need you on the.
It's not that type of, but all I'm asking is, I'm sorry I arrived late. I'm so disappointed. Will this be available on your website, the actual presentation? There's probably missed that information. Basically, that's all I need to know. We can't read it.
So the presentation is on the website and the supporting documents, the previous studies that are referenced are also on the website.
Thank you.
Go ahead.
Good evening. The lifespan of these units, is that still in the order of 20 years?
Well, analysis is typically carried out for longer periods, and there are wind farms that are already older than that. So it's going to be upwards of 20 years.
Considering what ours would be subjected to, hurricanes, et cetera, is it likely to go beyond 20 years?
Well, it would be designed to go beyond 20 years. As I say, the project lifetime in other jurisdictions and the way this is analyzed, it spans over 30 years. Currently, the standard is around 30 years. Can I answer that with certainty? No, of course not. But as I mentioned, this is designed to withstand very strong hurricane force winds, and therefore it could be expected that it would last for a very long time.
Okay. The other thing, you showed 3 different methods of installation. One pile driving, the other one a concrete bed. The second one, which is the one that concerns me, the concrete bed, which is generally tethered to the ocean floor with chain links, correct?
The concrete one?
Yes.
It's not tethered. It's pure gravity. It's a very heavy platform which
Yes.
rests on the seabed.
It rests on the seabed.
Correct.
So it won't have any impact on coral reef or anything of that nature.
The placement of the turbine is key here. The design needs to place the turbines in places where there's no coral cover. Otherwise obviously there would be damage. But that area that is being put forward, the coral cover is very sparse.
Okay, so we are to accept that the area of the island, which you have identified as the best possible area, where you will have 17 turbine platforms, if you go to that second option, won't impact any coral reef.
This is obviously not something I can guarantee at this stage. Once the design is completed, there will be a full environmental impact assessment of the proposed design. And at this stage, it will be clear whether there's any impact on coral. As we see it right now, we see a very large area that has virtually no coral cover. And this is the proposed site. And we think, as it stands, there won't be damage. Not something I can guarantee at this stage, unfortunately.
Fair enough. Going forward, when you start the more in-depth studies, if you find that it could impact, will you come back to the general public for more meetings like this to let us know just what's happening?
So once you get to a full design, it has to go through the planning process still. An environmental impact assessment must be done. Again, that is a public process through the Department of Planning. So there will be public engagement, not necessarily through us, but through the planning process. So there will be opportunity for residents to see the developments, see the environmental impact assessment, observe, comment, support or object to the development. Again, that wouldn't be through us, that would be through the natural planning process.
Thank you.
Good evening. Thank you for your presentation. I've enjoyed it very much. But my question is, could you shed some light on Taiwan, which is a hurricane-prone area, and the challenges they faced with dealing with the turbines during the hurricane season?
Well, I suppose I can't provide too much more detail than what I have provided. They have selected the appropriate equipment. The equipment comes from a variety of manufacturers, and typically they opt for a slightly larger turbine. The smallest one they have in their developments is 6 megawatts, which is likely unsuitable for the location in Bermuda. But I suppose the key thing is they have selected the right equipment, which is suitable for that wind regime, for the extreme weather. They have engineered the right solution in terms of installing those turbines and anchoring them to the seabed, and it seems to be working.
Martin, in previous presentations, you mentioned that the wind turbines in Taiwan were able to withstand up to Category 5 hurricanes. Is that correct?
Correct, yes. So Category 5 gust, so that's 155 miles an hour.
A couple of times you've mentioned the 150-meter limit from the airport. What is the standard height of a wind turbine? And does the 150-meter limit our choices, or your choices?
Yes, it does limit the choice of turbines. So I suppose there's no typical height. Turbines have changed quite a lot over recent years. What was considered a very large turbine 10 years ago is probably quite standard now, and the sizes have doubled. I think about 7 or 8 years ago, the largest turbine was in Scotland, and it was 7.2 megawatts. And now people are installing 15 megawatt turbines. And these are the height of the tip of the blade is over 200 meters, 220, 240 meters. The ones we selected for the concept design, the tip height is 135 meters. I can't remember the exact figure. It was something, not an even number. And any developer would be limited by those 150 meters. They could select a different turbine, but the likelihood is that the capacity wouldn't differ dramatically from what we thought.
So it's the height that's limiting kilowatt production.
Well, the larger the turbine, the larger the swept area of the rotor, the more energy can be captured. But obviously, the larger the area, the longer the blades, so the higher they reach.
To put it in I guess, a bit of reference, our tallest point is Town Hill, which is just under 100 meters. Again, and the site that the blade we are looking at is 135 meters. Again, so just to put it in a bit of context. Maybe some of the tallest turbines now is just as high as the tallest buildings in the world. I think for a bit of reference.
Since I'm holding the mic, I had a couple of questions. The first one is, would you comment on how we have a reliable electricity during those periods of no wind? And then I have another question in terms of, are we able to determine the exact location of this site? You know, I saw your map and the colors on it, but I'd actually be interested in going out and taking a look at the area from a point of both environmental cover and also cultural material like archaeology and shipwrecks.
So starting with your last question, so shipwrecks were considered. If you go back to the presentation, they were identified as part of our screening activities. So they were overlapped on our maps. So we were sure to avoid those areas. The location, again, it is identified in the presentation and probably more so in the actual report, which you will find on the website. It is about 8 square kilometers, so it is a fairly large area, and again, it's mostly bound by the constraints, primarily between the coral cover. So if you just happen to be on a boat out that way, if you follow the outline of the coral, you'll probably be on the edge of that area. On energy security and reliability, so the IRP is what. Our integrated resource plan is what determines or sets the energy roadmap for Bermuda. Wind was identified in the energy roadmap along with solar, fossil fuel generation, and actually biomass in the future. So every solution which will come from the IRP ensures a reliable supply of electricity. So with wind and with solar, when the sun doesn't shine, when there's no wind, there still will be a reliable source of electricity. Right now, it is fossil fuels will still be used as a primary fuel source. From the wind, as it sees about 30% of our expected to be about 30% of our demand, that will help to mitigate or lessen the use of fuel. It will not eliminate it. It will help to lessen our consumption of it. So that is quite important to note. We still need to require firm or baseload generation to supply our demand.
If I could jump in, on your question about the area, you mentioned that you're interested at this specific point, but wind turbines are typically spaced by quite a lot, so almost the entire area would be taken up. Most of it would have no turbines on it because they have to be spaced by around 10 diameters. If you imagine the diameter of the wind turbine, times that 10, and that would be the spacing between two turbines across the on the wind direction, prevalent wind direction.
I think what he's asking for is GPS coordinates, so we can go out there and drive around.
Oh,
the area.
right,
That's-
okay.
We're looking for a way to go there.
Right, okay.
Yeah.
Coordinates. These can be provided. Yeah, I suppose we can add them to the presentation.
Presentation, that would be on the RA's website, so check back on that. And there's an entire page dedicated to offshore wind at www.ra.bm. So those coordinates will be added to that presentation.
So I believe they are in the report, but we can add them. We can add them to the presentation as well, for ease.
Hello. Go ahead. Thank you. I was going to say ladies first, but okay. Thank you very much for this presentation. It's very well done. Nigel, Charmaine, Abayomi, whole RA team. Martin, thank you. I have a couple of questions. Maybe we can do them rapid fire. It's 60 megawatts, not 60 megawatt hours, right?
Correct. Yes.
Okay.
Capacity is 60 megawatts.
Do we? Is there any kind of a best guess based on wind patterns what the megawatt hours are going to be in terms of power output?
Yes, yeah. Our simulations point towards 180 gigawatt hours per year.
Okay, so awesome. How many households could that potentially offset based on, like, let's say a 30 kilowatt hour day?
So it's about just under a third of our demand.
Okay.
So at, let's say, approximately 33,000 customers, you're looking at 11,000 customers.
So just a small piece of feedback. That's great. I didn't know that, and I think something to share with everybody would be maybe to convert it into kilowatt hours with best guesses. I mean, you can then make the argument that this is offsetting like a third of the diesel that Belco would otherwise burn, right? That's awesome. I guess the other question is there a target customer in mind, or are you just going to net meter it back to Belco?
So it will be selling all to the grid, and then the intent of these bulk generation developments is so that all customers can benefit for a cheaper electricity, a rate for cheap electricity generation.
Cool. And then last question. What was the estimated cost? It was like 250 million initial capex, right?
250 to 450, so say midpoint of 350 million.
And yearly OpEx, what does that look like?
I think we took 2%, I believe.
2%?
Which of capex, which is a very high-level way of estimating it. But we don't have better estimates at this stage.
Okay, yeah, that's it. Awesome. 1/3, that's awesome.
Hi again. Sorry if you've already covered this and I missed it. My thoughts and concerns based on my experience. I've lived on boats for most of my adult life and have lived off the grid using solar panels and wind generators. And there have been, there's the after of battery disposal, and I know we don't have that here. The lithium batteries are a challenge, so there's that question. Waste, is there a plan for repurposing, or how do we deal with waste? And the second is, have you already done or are intending on doing environmental impacts of noise and sound pollution? Because that was an issue for us and our neighbors. And my concern is regarding cetaceans around the island. We have a resident population of dolphins and migrating whales, sorry.
I can take the first part, Martin. Sorry, remember again. Environmental impact assessments. Sorry, your first question again? Yes, wait. So, as with any development or anyone who acquires a license, along with the development, decommissioning is also a part or responsibility of the licensee. So they are required to, as they are required to develop, they're also required to remove any and the equipment upon the the end of their license. So decommissioning and removal of the assets is a part of the development as well.
I mean, along maintenance though, so as you go along, do these work similar to, you know, personal or household generators that depend on, you know, the energy's going into? I don't know how it works. Do you still have to operate using lithium batteries, the same concept, or is it totally different?
No, so there are no batteries. So there are no batteries with this development. It'll be, I guess, as I can compare it as simply to put it, if you have a fan in your house and if you blow it, it'll be simply operating on that principle, strictly wind-based energy. Yep, and a straight conversion directly to the grid. No batteries are involved at this point. We have assessed the use of batteries. We have determined that it is not needed or required at this time. Martin, you want to touch on the?
Yeah, noise pollution. It's 9 kilometers from shore, so noise pollution with respect to the population of Bermuda is unlikely to be an issue. For marine life, yes, this is identified as a potential issue, especially during construction, if there's pile driving. There are mitigation measures, like, for example, picking the season when the construction takes place, being outside of times when mammals are around, for example. But it is something that needs to be considered.
So have they done the assessments, or are they?
No.
They have, okay, so is there a need for supporting data or research to help identify that? Because I work for Dolphin Quest, and if there's support needed, we have those contacts. You know, the Wild Dolphin Project is coming back again, and so we know there are the resources available. So I didn't know if that's already been started, or if there's potential for support to provide that data.
I think that would be very, very useful, first of all, if there's more information. So where we are right now is there was an environmental scoping study, so desk-based, publicly available information, plus some other specialized reports. And this is what we've done so far. But a full environmental impact assessment is the next step. And this is pending a detailed design, because the equipment has to be known, the exact placements of the turbines have to be known. And then this is the next document, which is going to be the more detailed one.
I know it has been a concern recently in the news with other jurisdictions like Australia, even the New Jersey shoreline with beach marine mammals. So thank you.
So yeah, we always looking to get the most relevant information. So please, should we get your contact before we go? And we would definitely encourage getting more information.
I must say, my nephew and his partners and his organization, RA, I must say that tonight was very good clarity. I really understand everything, and I'm proud of you, nephew, Nigel, and your team. That was excellent presentation. And my only concern as an auntie is the opposition of our Balco as you buying back into, you're selling back your, into Balco. How is the relationship? Because we don't want to get all this, I mean, we're doing all this setup and doing everything, all this groundwork you already done, and then Balco says, no, I'm not buying that. How is that? Can we just clarify the connection between RA and Balco when the actual setup's done? Yeah.
Right, sure. Nothing like an auntie in the audience.
Gotta find it. I don't want you to do all this work, and then we say we can't buy it back.
So at the end of the awarding of for the developer, there's a 2-year period between which includes application for the license, the permitting phase, the environmental impact assessment. As part of the application process, there is a series of information which they need to submit to support their application. Part of that is an interconnection agreement and a power purchase agreement with the utility. So the interconnection agreement, again, is a binding contract for interconnection to the network. And the power purchase agreement is a legally binding agreement for the compensation for supplying electricity to Belco. So there is a legal obligation with those two agreements to connect and supply a set amount of power, electricity, and for remuneration for that. The regulatory authority approves those documents. So we know what their agreements are. We know what the price is. If it is too high or too low, we will not approve it, and it will not be a binding document. I say too high or too low. Too high to make sure that it protects the interests of the customers. Too low because we need to ensure that the development is able to maintain its operations. We don't want somebody coming in and underbidding or bidding too low, in which case we find out a few years into the operations, they go bankrupt, and then they will not be able to meet the obligations of supplying electricity to Bermuda. So we must ensure that all parties' interests are met. Also, Belco, or the TDNR licensee, Belco in this case, again, is legally obligated to interconnect licensees, those that we deem licensees. And again, it's through those agreements which come with their application to us and approval from us. You want to add to that, Martin? Okay. So I hope that answers your question. So I guess the short of it is Belco does not operate in isolation. And again, they do not set the prices. That comes from the regulatory authority. So there is oversight in each of the process in the interaction between the developers and the utility.
Any further questions? You can take that, Mike.
Yeah, just a question on curtailment. We talked about cost today. Basically, Belco rides up and down every hill of Bermuda, maintains the exact 60 kilometers an hour speed, and when the frequency drops, they ramp up. When the frequency goes high, they slow down. This wind will help push Belco so we don't have to pedal. When the wind blows in a winter night and it's 60 megawatts coming to the grid, and all of us in Hamilton are only using 40 megawatts, there's 20 left over that we can't use. And you said that batteries are not needed for stability. And in the UK, we're paying excess for electricity because they're curtailing wind. Have we considered the curtailment in the costs that you've presented today with LCOE?
Short answer is no, they haven't been considered. There has to be a fairly extensive study of demand patterns and supply patterns in order to do so. There will be instances where curtailment is needed. But I suppose the key here is figuring out whether the curtailed energy is sufficient to warrant a storage solution. And this is a cost-benefit analysis for the developers too, I suppose. Now, as a follow-up to your question, there's always the question about how this is contractually set up with the generator and whether there's payments for curtailed energy. And this is something that needs to be laid out in the later stage of a project, but it's certainly something that needs to be considered.
And because we're an isolated grid, curtailment's going to be a bigger issue because we can't sell energy to France or the UK. We've got no interconnection. But in a bigger country, it's windy in Scotland, you can give it to London, or you can give it to France, Germany, and if windy in Germany, you can pass it around. We don't have that. So we've got to run a balance, and it's really important, but it's The other, if I can have one more question, we talk about gusts and sustained wind. And when you read class 1, they're rated to gusts of 156 mile an hour. And we call that category 5, but that's the bottom of category 5. So my question is, have the developers, and you look through the different standards and technologies, can you give some information on what they're rated at in terms of actual hub height wind speeds? Because everything for hurricanes is done at 10 meters above sea level. So all of this stuff is at hub height. There's a lot of gap. And I know this is a very technical question, but Bob, you measure wind on top of Wreck Hill. I heard in Fabian you measured what? How much did you measure in? And so we have locals with wind speeds measured at points on land. Now they're very different than obviously in the middle of the ocean where there's the shear is different. But these wind speeds for the de-risking, when you look at all of these issues, is there a risk register that you've built up that we can see and add to that shows the mitigations and sort of a complete list of risks for the island? Because I want wind to happen, but I want to mitigate the risks. One of the things you talk about the dolphins, you can add an air curtain around it when you pile, use hydraulic piling instead of hammering, and instantly you get rid of it. We should be measuring the sound of the reefs now to have a baseline data set so that we can then go back later and see have they recovered. Because in 30 years, we're going to be asking for more wind turbines, potentially. So the data collection, and I haven't spoken at any of these events because I kept quiet, but I'm home, so I gotta say my piece in Somerset.
All good questions. There is a difference indeed between the classification for a gust and sustained wind, and sustained wind is obviously lower. Sustained wind, I think for class 1 right now is at the upper limits of Cat 4, but it doesn't reach Cat 5. So that's definitely a risk. And this is something that a potential developer would be aware of. We haven't sort of created a detailed risk register at this stage because that's jumping the gun in a sense, but it's certainly something that needs to happen further down the line. And it's probably something that needs to happen early on, perhaps at qualification stage, and those developers need to be asked whether they have thought about these things and whether they have the equipment. Sorry, your next question was on...
I don't think you need to answer it now. I just want you to consider those things and engage with this is engage. It's fantastic. And I'll put this all on. I think what's key and it's missed is you can write down loads of things on this and submit it. You can go online and do it. And I work for Boca.
Yeah, thanks.
Any other questions, comments?
Is there a reason you chose 17 at this point in time?
Again, this is just a concept design. So we chose a turbine that met the requirements, and then we just came up with the right number to make up 60 megawatts capacity. Detailed design, as I already mentioned, a different turbine could be selected. If it's a 4-point-something megawatt, it would be a smaller number of turbines. So this is not something that is being prescribed right now at pre-feasibility stage. This is a concept, and it could change depending on available equipment and the preference of the developer.
So as I mentioned, there is a considerable amount of time between now and at the end of this development, again, potential development. There are numerous decision points. There's more information that is needed. So again, this is the start of our journey. Again, we will look to engage the public as much as we can throughout that journey. We have the integrated resource plan, the updating of the integrated resource plan currently underway. So from November, mid-November, we will expect to receive the IRP proposal from Belco. And again, this lays out the Bermuda's energy roadmap. And again, currently, it's again, a mixture of renewable energy and fossil fuel generation. In the next in the next iteration, again, all available technologies are considered. Again, the goal is to come out with a plan which is most beneficial to Bermuda, whether in cost, concerning cost, the economic impact, environmental impact, and also social and economic considerations. There is a full consultation process on this, expected to last throughout 2024. So we will be engaging you throughout that time. We encourage you to respond and provide feedback. And actually, the feedback is how we actually arrived at the 60 megawatts of wind. In the first IRP, I think it was over 900 responses in favor of a high penetration of renewable energy of 60 megawatts of wind. I believe it was put forward by Better Bermuda Energy Plan. Better Bermuda Energy Plan. Again, so we did listen to the public and their comments, and we used that into developing a plan which Bermuda wanted. So in short, we listen, and we look to consider all of your wants and needs in our work.
Going once, going twice. Thank you very, very much. It's a small group, but you're all so engaged. And on behalf of the Regulatory Authority of Bermuda, we thank you for taking time out to come out tonight and for your very thoughtful and thought-provoking questions. As Nigel says, they will be all taken into consideration. So no question, no comment is ignored. So thank you. God bless you. Eat up and be safe. Good night. Oh, that man doing jumping jacks over there is trying to remind me to tell you that on the RA's website, which is, don't let me say it again, ra.bm, there is a page that says town halls, yes, to the offshore wind town hall. When you get on that, there is a link then that will take you to another link where you can respond to the consultation. So you can upload any other questions about this presentation directly to the RA. The presentation is also on the website. So you won't miss a beat. They are really taking extra measures to ensure that you are well informed. Okay. And thank you once again. Good night.